DCS, or Distributed Control System. Anybody in here ever hear DCS other than me mentioning it? And grand total of nobody.
Dual check safety.
Well,
Distributed control systems.
Yeah,
That's what it is.
yeah, the dual check safety is certainly fits the acronym, but unfortunately that's not what we're talking about anymore. So what is a DCS?
Oh, okay.
Distributed Control System, or DCS, is an automated control system that is distributed throughout a manufacturing plant or industrial facility. So you can think of that as the master controller of a process. You have individual controllers on each of the machines or process lines, and then the DCS is the overseer and the master control.
Is that usually like a computer that controls all this stuff, or do they have a separate control console for
Well,
it?
it's usually run on a PC, and Wonderware is probably the most popular, the most common.
Say again, please.
Wonderware.
Wonderware. Okay.
Yeah, WONDERWARE. It consists of a network of controllers, sensors, and other devices that communicate with each other and with a central control system. I said the central control system is typically the traffic cop. It keeps track of what everybody's doing, frequently includes a data historian, so you can keep track of what's going on. Everything is timestamped, so you can see, especially if you're doing food and bev or pharmaceutical, that sort of thing. They do DCS a lot in those instances. DCS is used frequently in work cell. But the DCS is typically responsible for the data historian, which you want to keep track of pressure and flow and temperature and acidity and conductivity, all the other kind of parameters that you can monitor. Wastewater treatment, you have to worry about total dissolved solids and dissolved oxygen, all kinds of things, making sure that your UV system is working so you can kill all the bugs as the water is being processed. So the DCS is just a really convenient place for everything to come together, all the data to be stored in one place and visible in one place. Definition: DCS, control system where the control functions are distributed across multiple controllers located throughout a facility as opposed to being centralized in a single location. So let's say you have PLC or some other type of controller on each machine, and the DCS is the traffic cop. It keeps track of everybody. Components: controller, programmable devices that control specific processes or sets of processes, PLC. Sensors and actuators, devices that collect data from the environment and execute commands from the controllers. So that's your temperature, pressure, flow, and all that. Then you have the valves and the switches and whatnot. HMI, human machine interface. Interface allows operators to monitor and interact with the system. When you're talking about HMI, most people think of touchscreen. that technically is an HMI, but is more accurately referred to as an OIT, or an operator interface terminal. HMI is whatever you use to interact with the machine. You know, this is an HMI. I'm using it to interact with the computer right now to control the slideshow.
But that's not a terminal, is it?
No. HMI can be as simple as push button and pilot lights, all the way up to and including, you know, touchscreen, whatever. When I say touchscreen, is more accurately referred to as an OIT. Communication network infrastructure that enables communication between controllers, sensors, actuators, and HMIs or OITs. Nowadays, it's almost always going to be Ethernet IP. Though the other technologies do still exist, you know, Modbus, Profinet, Profibus, CAN, you know, everything we've talked about in the past. The centralized monitoring and control stations are locations where the operators can oversee the entire system and make adjustments as necessary. So with the DCS, you can actually have operator stations positioned around the facility, and you can make adjustments to or monitor processes on a machine that's halfway across the plant if that information is allowed to be displayed on that device. As a keyboard and mouse or a touchscreen or whatever, you can also potentially interact with it. You want to be really careful when you do something like that, though, because if you're adjusting a machine that's halfway across the plant and you can't physically see it, you know, you may be telling it to do something that you really don't want it to do. Process control. DCS systems are used to automate and control manufacturing processes, ensuring that they run smoothly and efficiently. Manage tasks such as regulating temperature, pressure, flow, level, all that stuff. Data acquisition and monitoring. DCS systems collect data from various sensors distributed across the plant. Data is used for real-time monitoring, historical analysis, and process optimization. Pardon me, again, whenever you're talking about food and bev or pharmaceutical, you must keep that information, because if you know, you get a Wisteria or an E. coli or whatever outbreak, you have to be able to show what the conditions were when you processed whatever the food or pharmaceutical was. Did we talk about the Tylenol?
Yeah. What happened?
Help me out here, Drew. You remember that whenever the Tylenol?
I remember it, but I don't remember the.
That was like way back in the late 70s, early 80s.
I don't remember I remember it, but I don't remember the instances about it. What was it? Some kind of impurity in it?
Tylenol was laced with cyanide.
Oh, that's right.
Yeah, and people started freaking out because, you know, oh no, Tylenol laced with cyanide. So they started looking at lot numbers on the boxes. They're all stamped or printed.
Rat poisoning?
With lot numbers, production dates and whatnot. And instead of being able to narrow it down to a single production run that could have potentially been compromised at the processing facility, the pharmaceutical, it was across a bunch of them, many different plants.
Uh-oh.
So, okay, that almost always says that it was not a single, wasn't a production problem. As it turns out, there was some guy that decided he wanted to kill somebody. In order to do it, he was going to poison him with cyanide, make it look like an accident. He put it in Tylenol, and he decided that hey, if I only poison the one person with this your one bottle of Tylenol, then they're going to suspect murder. But if I contaminate a bunch of them, and a bunch of people die, or at least get sick, then they'll think that it was Tylenol's fault, not mine.
Yeah.
That's,
So, yeah, the codes that you see stamped on the boxes and the bottles and whatnot for pharmaceutical and all that, that is one of the ways that they keep track of when it was produced, all the conditions that were, you know, in the process line and all that stuff. Scalability and flexibility. Because they're distributed nature, DCS systems can easily be scaled and adapted to changing manufacturing needs. New controllers and sensors can be added without significant disruptions. So you need to add a machine or even have full line, an entire wing, you know, whatever it is, you can add it to your DCS without having to shut everything down in the process. So makes it really nice. Redundancy and reliability. DCS systems are designed with redundancy to enhance reliability. One controller fails, others can take over its functions, minimizing downtime and ensuring continuous operation. It'll also throw flags that say, hey, that machine, local controller is faulted or broken or, you know, whatever the problem is, and alert maintenance, hey, you need to go fix it. Since other systems can take over the function, you can get through your production run and then bring maintenance in instead of having to shut production down while you fix that line, and then, and depending upon what's wrong with it anyway. If it's a problem with the controller, you know, that's one thing, but if you got bad sensors or bad actuators, unfortunately, then you do have to shut it down because there's nothing the DCS can do about it. Safety and alarm management. DCS systems incorporate safety features to detect abnormal conditions and trigger alarms, or automated shutdown procedures to prevent accidents. Anybody ever heard of 3 Mile Island or Chernobyl?
mm-hmm. Yeah. It's a darn shame ever since.
Those were both controlled by DCS.
Oh.
And they melted down anyway. Integration with enterprise systems. DCS can be integrated with higher level enterprise systems, such as manufacturing execution systems, or MES, and enterprise resource planning, or ERP systems, facilitating better coordination and data sharing across the organization. I've never personally dealt with an MES, but most places have an ERP, enterprise resource planning, and that's where you keep track of your inventory, your orders, where things are at in the production process. Are you going to meet your deadlines? You're going to be able to fulfill your orders. You're going to be short, you know, late, that kind of stuff. Energy management. DCS systems help optimize energy use by controlling and monitoring energy consuming processes, leading to more efficient and cost-effective operations. Okay, it takes the energy that it takes to run a machine, so I don't know how DCS is going to help to optimize that unless, you know, it can detect that the machine is just sitting there idle, consuming a bunch of electricity while it's not doing anything. You could shut it down in that case, I suppose. Examples: chemical manufacturing, controlling reactions, blending processes, managing chemical storage and distribution. You can imagine a lot of the chemicals that we're capable of making nowadays are really nasty, extremely toxic, potentially corrosive or explosive,
Carcinogenic.
flammable, carcinogenic, you know, a whole bunch of different things that can go bad whenever you have a problem with chemical manufacturing process. oil and gas, mining, or managing drilling operations, refining, pipeline control. You ever watch YouTube videos where they have the storage tanks out in the yard at the refinery and something goes wrong and it explodes?
That's a big boom.
Yeah.
Explosion.
The bad part about oil and gas is the gaseous form of it, the vapors. So those big tanks that you see out in the yard at a refinery, the lid moves. It rests on top of the liquid level so that there's no gaseous vapor
Oh, really?
in the tank. Yeah.
I don't know, man.
Yeah, I didn't know
Those occasionally get stuck.
Uh-oh.
Like
That
that.
could be bad.
So you get that gaseous buildup and all you need is the right spark. And then the whole lid goes.
You know, considering the fact that gases, when compressed, actually kind of heat up, I can imagine just pressure building in there and the heat alone.
That is a possibility too, yeah. It's called dieseling.
This was it's not igniting, it's the pressure that.
It just reacts.
Yeah. That's how a diesel engine works.
Yeah.
The glow plugs are only there to get the reaction started. Once it starts running, turn the glow plugs completely off and it'll still run. Power generation, controlling turbines, boilers, other equipment to ensure efficient power production. The power grid is something that is really, really way more sophisticated than people realize. You know, the generators and all of the power production facilities around the world have to run at exactly the right speed all the time. So here in North America, US, half of Japan, lower half, by the way, power is generated at 60 hertz, 60 cycles per second. Pretty much the rest of the world is 50 hertz.
Yeah, but some countries are like in Europe it's 220 and here it's 120.
It's 220 here too.
Yeah.
I mean, for residential.
Yeah, it's 220 here also.
Oh yeah, for the dryer.
Yeah.
Mm-hmm.
You have 110 volts at your outlet because the transformer is center tapped.
So in like the residential, do they bring in how do they bring in that extra power?
Through a transformer.
Or within the house, the panel?
No, the transformer's out on the pole.
On the pole? Or so they make two separate
That's why they call it a triplex. The cable that runs from the pole to your weatherhead, to your meter, and then inside the house. Because you got line 1, line 2, and neutral.
Yeah.
Oh,
Yes.
Anyway, the speed of that generator has to be controlled meticulously. If it gets too fast or too slow by like half a hertz, half a cycle per second, it can do really bad things to devices that are connected to the electrical grid, like TVs and computers and things like that. So, pharmaceuticals, regulating mixing, heating, cooling processes to ensure product quality and compliance with regulatory standards. Anything that is meant for human consumption, but especially pharmaceuticals. especially if it is directly injectable into the bloodstream. You want to make absolutely certain that you control that process to as tight a standard as you possibly can, because one thing you don't want to do is start injecting things directly into people's bloodstreams, which bypasses 95% of the immune system and make people sick or kill them. So your DCS is going to keep track of all that stuff. Make sure that, you know, if it needs to be at this temperature or, you know, this pH, you know, whatever the process requires, you're going to monitor that and make sure that it stays within a really fine band. So there's always a tolerance, you know, plus or minus whatever. But you got to make sure you stay within that. I worked at Universal Flavors up in St. Louis. We made the flavorings that go in ice cream and yogurt.
Oh, cool.
And we started in September. We worked all the way through till the end of the year making eggnog bases.
Wow.
Every line in the building
Was eggnog.
was nothing but eggnog.
Holy shit.
That sells.
Yeah, I hate eggnog.
That stuff must have, the smell must have.
Oh, yeah. But in order to make sure that that is safe for human consumption, it's processed at a specific temperature for pasteurization and all that, because the eggnog is actually made with eggs. And once you break the shell, you have to worry about bugs and yeah, that's one of the bugs I was thinking of, but thank you. Now, Salmonella, E. coli, all things that can become foodborne. Eggs are really susceptible to, so you have to control the temperature. You want to keep it refrigerated until you're ready to process it. And process it at a specific temperature to make sure that you can kill anything that's in it and then cool it back down, keep it refrigerated so that new stuff can't get in and grow. In summary, DCS is crucial for modern industrial manufacturing, providing precise control, enhanced reliability, and flexibility needed to manage complex and large-scale operations effectively and efficiently. And that's that.